When determining whether or not a rational function has a horizontal asymptote, we have three cases we need to attend to. So p is the numerator of our rational function, q is the denominator. If the degree of the numerator is smaller than the degree of the denominator, in other words, if the degree of the denominator is bigger, imagine having a fraction with a huge denominator. It's really close to zero. So if the degree is bigger in the denominator, the horizontal asymptote is automatically the line y equals 0. If the degree is larger in the numerator, so now we have a fraction that has a really big numerator, there's not going to be any horizontal asymptote. The numerator is growing faster than the denominator. If the degree of the numerator is equal to the degree of the denominator, they're growing at about the same rate. So the horizontal asymptote is at what's called the ratio of the coefficients of the leading terms of p and q. So we're going to take a quick look at some examples and see how we can use these shortcuts to determine. So, example number 1, f of x is x minus 3 over x plus 2. So we want to look at their lead coefficients, their leading terms. Both of these have the same degree. So it's going to be at the ratio of their coefficients. So 1 and 1 are the coefficients. So this is a horizontal asymptote at y equals 1. On to G. I have a second degree on bottom. Now it may not look like a second degree initially on I have a second degree on top. It may not look like a second degree on bottom initially, but imagine foiling this out. Now we don't need to. We're just trying to determine if there's a horizontal asymptote. So we have a degree 2 over a degree 2. This is the case where we use the ratio of the coefficients. Coefficient of the numerator is 3. If we were to multiply these two terms together, it would just give us an x squared. So it has a coefficient of 1. So our horizontal asymptote is at 3 over 1, or y equals 3. All these can be verified by graphing them. H of x. Here's our lead coefficient. Here's our leading terms. Degree is greater in the numerator. That means top's growing faster than the bottom. No horizontal asymptote. Last one. Our leading terms. The degree is larger in the denominator. The denominator is growing faster. It's going to pull this thing down to 0. We have a horizontal asymptote at y equals 0. And those are the three cases and how we can determine them just given the equation without even looking at a graph or a table.